Today we will discuss about crystal field theory or CFT. The CFT developed by H. Beth and V. Black in 1935. They gave more successful explanation of bonding and properties in coordination complexes than VBT. According to CFT, bonding between a central metal ion and ligands arises from purely electrostatic interaction. If the ligand is an ion, the attraction towards the cation is as that between any two opposite charge particles, and if the ligand is neutral molecule, the negative end of the dipole is attracted towards the central positive ion. Knowing the arrangement of ligands around the central metal ion, the ligands assuming the bond between metal ion and ligand to be purely electrostatic, and consider the metal ion and ligand as point charges Q1 and Q2 separated by the distance r, the metal ligand bond energy can be calculated by the formula binding energy equal to minus Q1 Q2 upon R. The d orbital can be divided into two groups depending upon the nature of their orientations in space. One of the group consists of three orbitals which are in the region in between the axis, while other group consist of two orbitals which are along the axis. In the case of free metal ion, all the five orbitals have the same energy, that is, they are degenerate, means energetically equal. So now we will see that how the energy level splits in octahedral environment. Firstly, we consider a hypothetical case in which the set of 5d orbital of the metal ion is spherically surrounded by the uniformly spread negative charge. The electrostatic repulsion between d electrons of the metal orbital and the orbital of ligand would result in uniform increase in the energies of the d orbitals. In other words, although the orbital acquire high energy, they would still remain degenerate. Now consider that the negative charge surrounding d orbitals of the metal ion gets concentrated in a number of point charges in certain specific position. The energy of the orbitals lying in the direction of the point charges would be raised to a large extent than that of the orbital lying in between the point charges, because the electrons in the former type of d orbital would experience greater repulsion from point charges than the electron in later type of d orbitals. This means that some of the d orbital would get associated with a higher energy than the other d orbitals. The splitting of 5 degenerate d orbital of metal ion into sets of orbital having different energies is called crystal field splitting, and this concept forms the basis of CFT. Now we will see the crystal field splitting in octahedral complex. In an octahedral complex, the coordination number is 6, the metal ion is at the center and the ligand occupy the 6th corner of octahedron. In the octahedral complexes, the two orbital of the metal ion dx square minus y square and dz square are oriented along the axis and they are designated as Eg orbitals, while other three dxy, dyz and dzx are oriented in between the axis and they are designated as T2g orbitals. As the 6 ligand approach the central ion along the axis, if electron present in Eg orbital is repelled more by the ligand than if it is present in T2g orbital. That is, the energy of dx square minus y square and dz square is much more than the energy of the dxy, dyz and dzx orbital. Thus, in octahedral complex, the 5d orbital splits into two sets, T2g and Eg. The crystal field splitting in octahedral complex can be shown in figure. The crystal field splitting is measured in terms of the energy difference between T2g and Eg orbitals. Delta naught, thus you can see delta naught where the subscript naught indicating octahedral complex. The state first represent degeneracy, same energy of all the 5d orbital in isolated central ion metal. Then state second represent hypothetical degeneracy of all the d orbital at the higher energy level. Assume that ligands are uniformly affect the electrons in the d orbital of the metal ion. The state third represent crystal field splitting. The crystal field splitting is generally measured in terms of parameter dq and by the convention of delta naught is taken to be equal to tan dq. Now we will see crystal field splitting in tetrahedral complex. Tetrahedral arrangement and 4 ligands around the metal ion. The coordination number for tetrahedral complex is 4. The tetrahedral arrangement of 4 ligands surrounding a metal ion may be understood by the place the ligand at the alternate corner of a cube as shown in figure. It can be shown that in a tetrahedral structure, none of the d orbitals of metal ion point exactly towards the ligand. The 3d orbitals dxy, dyz and dzx are pointing close to the direction in which ligands are approaching, while the 2 orbital dx square minus y square and dz square are lying in between the ligands. As the result of this, the energy of the 3 orbital dxy, dyz, dzx increases compared to the energy of the 2 orbital dx square minus y square and dz square. This is because the electron in 3 orbitals would be repelled by ligand electrons more strongly than electrons in the 2 orbitals. So the d orbital are again split into 2 groups but in the reverse order. The 3 orbital are designated as T2 and the 2 orbital designated as E. And this is the crystal field splitting in tetrahedral complexes. Thank you.